Hello, you're listening to Inside iOS Dev, a show about real-world iOS development, here with your host, Andrew Rohn.
And Alex Bush.
Today we have two very special guests, Vincent Ngo and Kelvin Lau, here to talk about their new book, Data Structures and Algorithms in Swift. Vincent Ngo is a principal software engineer at Capital One. He's been an iOS developer and Ray Wenderlich contributor since 2014. And Kelvin Lau is currently a senior iOS dev at Applied Digital and has been an iOS developer since 2014. And he currently maintains the Swift Algorithm Club at raywenderlich.com. Okay, so I guess today we want to talk about this book, Data Structures and Algorithms in Swift. Looks great. We were looking at some of the chapters, and it looks like it really covers the kind of your standard, I would say, what I received in my computer science education as a bachelor's, as stacks, queues, binary search, things like that. Maybe you guys can explain a little more what this book is trying to achieve and why you wrote it.
Yeah, I think this book is mainly to teach those concepts that you learned in university. Not all iOS developers come from a computer science background, and if you didn't take those data structures and algorithm courses, you would want to read that book to build your understanding in that area. One thing that's different, our book is different from your typical university courses. We use generics a lot. So in addition to getting more informative or knowledgeable in data structures and algorithms, you're going to get better in using Swift generics and the Swift standard library.
That is an interesting approach. I actually, now I think about it, I've never, I guess this kind of computer science algorithms, I've never seen them implemented, using generics, right? Usually the examples would be in C, C++, something like that, more low level, right, with pointers and such. So how's that? Why did you guys decide to use generics, and how is it different?
I think in school they want to lower the bar of entry as much as possible, so they don't teach much of the data structures and algorithms generically. They use concrete types, which is easier for the beginner to understand. For our book, we want to do something a little bit different. We want to do it in a generic way, which makes things more interesting for more experienced developers.
Okay, so actually, would you say what experience level would this book appeal to? Is it of all levels or a certain type?
That's an interesting question. I think I got comfortable in generics on my in between my first and second year of iOS development. It depends on if you have experience with a different language before and generics. But I definitely think it's not for complete beginners. You would want to be fairly good in the Swift language.
Okay.
Starters. We use like map, filter, and reduce without much reserve.
Okay.
Yeah, you would want some experience before diving into this book.
Would you guys say that this book would help you if you're preparing for an interview?
Yeah, definitely. Especially if you can master generics. I think writing generic code in an interview is going to surprise your interviewers and make a really good impression.
Can you dig into a little bit more about, because I guess generics has come up twice now. What kind of briefly, what is it, and why do you think it would surprise interviewers? Like what's special about generics?
Yeah, so writing generic code is to write code in a way that is reusable, and it requires a deep knowledge of the Swift standard library to do it, and the Swift collection protocols in general.
Yeah, and also in our book, not trying to advertise or anything, but with some of our data structures, we start off with a protocol. And for example, the queue, we start off with a protocol where it breaks down the fundamental operations of the queue. So in a way, and aside from learning like data structures and algorithms, you learn about how to develop like the API of the queue using protocols.
And so, what do you think? So this is written in Swift. Do you think what are some of the advantages or differences of writing this book? Because I would say this sort of data structures and algorithms book is fairly common kind of topic. So there's other books on this sort of topic. But what do you think the differences are here because you've written it in Swift?
Third time, Swift generics. I don't think a lot of books have a focus on that. We do. We have a strong focus on using protocols and writing the algorithms and data structures in terms of the Swift collection protocols.
Right.
These are advanced Swift features that books generally don't use, which does raise the bar of the book a little bit, but I think it's important for Swift developers to eventually get natural with working with generics and collection protocols. In fact, there's at least two talks in this year's WWDC regarding Swift generics and embracing algorithms.
Interesting. So do you guys, can you maybe quickly describe what some of the algorithms actually are, right? Like I have no idea what your algorithm, I think it's a chapter 22 in your table of contents. I don't even know how to pronounce this.
Dijkstra's algorithm?
Dijkstra's, yeah. What is that? I never heard of that. I guess I didn't study in school that well.
Shouldn't have slept during that class, man.
I know, right?
So Dijkstra's algorithm is part of the graph theory. So with graphs, you can implement it in like using like a adjacency matrix or like an adjacency list. And basically with Dijkstra's algorithm, it helps you find the shortest path from the starting vertex to any other vertex within the graph.
So, and when would you apply this? In what scenarios?
Yeah, so with Dijkstra's algorithm, maybe it could be like, let's say, a game in a maze. You could find the shortest path from the start of the maze to the end of the maze. Or let's say on like Google Maps, for example, you need to get from point A to point B. What's the fastest way you can get there?
So I want to list actually kind of some of the table of contents here that I can see. We all talk some of the topics you hit. You talk about the Swift standard library, linked list, the stack, queues, trees, binary search trees, AVL trees, tries, I think is it pronounced, binary search, heap data structure, priority queue, sorting algorithms, merge sort, radix sort, heap sort, quick sort, graphs, breadth first search, depth first search, Dijkstra's, which we just talked about, algorithm, and Prim's algorithm. What made you choose these?
Oh yeah, so like I said before, we kind of did our research, like kind of looked at other like data structures and algorithm books, and also like college books to see what kind of common data structures that other professors teach day to day, and we kind of list them. So these so far pretty. Kelvin, would you say that these are pretty foundational data structures and algorithms that students start learning before going to more advanced data structures?
Yes. Yeah, I totally agree. And I just want to mention that our tech editor, Steven Van Impe, is a professor at a university. So,
oh yeah, that's right.
Oh, that's great.
Oh,
yeah,
wow.
That's great to have as an advisor.
Yeah, he definitely helped out determine what types of the algorithms, data structures we want to put in the book.
I have a question that I'm actually interested in. Do you guys have a favorite data structure?
Personally, for me, since I wrote the graph theory chapter, I'm pretty. I think I've had a general appreciation and kind of fell in love with that topic.
For me, I think I like the trees, especially tries or AVL trees.
Yeah, I'm a big fan of, this is going to sound so simple, but I'm a big fan of dictionaries or hash maps or whatever. Even though
I love those too.
They're so simple, like, especially in interviews, like I think like a little mental hack, if you want to call it that, is like if you get an interview question and like you spend more than a few seconds and you can't figure out where to start, just like see if like you can put a dictionary somewhere in there. And I've often found that's like a pretty good place to start, because they're amazing. They give you that constant time lookup. So
that's a great tip. I have that rule of thumb as well.
Yeah. How many of these data structures and algorithms are actually baked into the Swift standard library? I'm curious.
They definitely use trees somewhere. The thing is, they don't expose many of these data structures and algorithms to public,
right?
But they use it to build certain data structures,
right,
for their other components,
right?
Kelvin, what was the other one where they use like an intro sort and insertion sort or something combining together?
Oh yeah, that's an interesting one. So the sort method from the collection protocols.
Yep.
Like if you call sort on an array, for example, they use something called intro sort, which is a combination of the insertion sorts and the heap sort, I believe. And depending on the size of the array, it will choose one or the other.
Yeah, that's a nice thing when you get these nice standard libraries is people who study this a lot more than you might have time to do, they kind of abstract those details away, which is nice. But sometimes it's good to know the things, like I was saying earlier. Sometimes you can't rely on the whatever's given to you, and you have to kind of hand roll things. So this is good knowledge to have in that case. I'm also wondering about this Swift Algorithm Club. Can you tell me about that?
Sure. The Swift Algorithm Club is GitHub repositories where people contribute their knowledge on data structures and algorithms. For example, we have linked lists, we have trees and graphs, and people just write up a short article about it and write some code and contribute it to the community. And Vincent and I would review it, polish it up a little bit, and get that merged for everyone to read.
Oh, so that's kind of like a community way of learning this sort of knowledge.
Oh, yeah, definitely.
Great.
Yeah, and also really just want to shout out to all our contributors on the Swift Algorithm Club, and also Matthias Hollemans, who started this GitHub repository, because without it, we probably wouldn't have started writing this book.
Oh, nice.
So, yeah, thumbs up.
Yeah.
Thanks, guys.
Hope they're listening. I'll send them the episode.
Yeah. Yeah.
Okay, looks like we're kind of getting towards our time limit here. Alex, did you want to ask any questions?
No, I'm feeling ignorant. So
well, sometimes the ignorant questions are good, right? For those listeners who are in the same boat as you, right?
Right. But yeah, for me, I guess, I just want to read the book now.
Is there anything you guys wanted to mention or cover? I want to do a shout out to our editor, Stephen Van Impe, our English editors, Manda and Chris, and also our Final Pass editor, Ray Fix, for writing the book with us, or editing and guiding us.
Where can we find this book, and where can we find out about the Algorithm Club?
Yeah, so you can find the book on raywenderlich.com, and also the GitHub repository for the Swift Algorithm Club is just if you just search Swift Algorithm Club on Google, you'll probably find it, because I think it has over 14,000 stars, so you can't miss it.
Nice. And we'll also add both of those links to
Great. Yeah, we'll add those to the show notes. Cool. Also, another thing is Ray graciously gave us, I think, 1 or 2 books, maybe a copy of the book to give away. So we're also going to add that to the show notes, so you guys can go check that out and, enter to win a chance to win a copy of this book. Cool. So I guess, Alex, anything from you? You want to close out?
No, let's close out. You guys can reach out to us at hello@insideiosdev.com, and on Twitter. What was our handle?
At InsideIOSDev on Twitter.
Yeah, and we'll thank Vincent and Kelvin. Thanks for coming. And
Yeah, thanks, Andrew, Alex.
Thanks for having
Appreciate
us.
it. Yeah.
Yeah.
yeah, and
Take care.
take
Bye.
care.
Cool. Thank you.
Thank you.
Bye.